Welcome back to Tech with Mo. Today we're going to learn about data pre-processing in Python, a crucial step in preparing data for machine learning. Whether you're new to data science or looking to strengthen your skills, this tutorial will guide you through cleaning, exploring, and visualizing data using Python libraries. Let's dive in. We'll be using Google Colab for this tutorial. Which is a free online coding platform. It's great because you don't need to install anything. Just open your browser and start coding. Let's begin by importing the libraries. So first let's create the file. We're importing Pandas, which is like powerful spreadsheet for Python. It helps us read, manipulate, and analyze data. We've used Seaborn is a library for creating beautiful visualizations, and it works well with Pandas. We also used Matplotlib is another plotting library. While Seaborn builds on Matplotlib, sometimes we use both for more flexibility when creating charts. Next, let's load a simple dataset to work with. We'll use the famous iris dataset, which contains measurements of different types of flowers. This dataset is perfect for beginners. You can also download the iris from here, the dataset. So we'll go back, and what I like about Google Colab, let's run this and type our data here, df dataset. In a moment, so df.head, this will display the first few rows of the dataset, and here, what is the issue here is, okay, we missed, what did we miss here? Okay, it's kind of weird. Let's figure out, it's fine. Sorry, type again. Yep, it's working now. I think it's a misspelling we missed or something. So we go to this here. So we load let's run it first. Okay. We load the iris dataset using SNS load dataset, which is a built-in function that provides access to several sample datasets. By calling the df.head, we display the first 5 rows of the dataset. This gives as a quick look at the structure of the data and what kind of information it holds. You'll see here in the columns like spal length, spal width, and petal length, petal width, and species. This represents different measurements of flowers and their species type like Cetosua, versicolor, and Virginicea. Before we clean the data, it is important to understand what it looks like. Let's check if there are any missing values and get some basic statistics. So print. So here, this is null dot sum function checks for missing values in each column. It's important to know if there are any empty cells, as they can affect our analysis and model performance. So let's run this, and it shows we have 0. The describe here, we've used describe. The describe function gives us summary statistics like mean, minimum, maximum, and quartiles. This help us understand the range and distribution of each feature, like the lengths and widths of flower parts. If there are no missing values, great, but if there are, we'll need to decide how to handle them. The summary stats give us insights like the average spell length or the range of petal width, but as shown here we have 0 for the moment. So now visualizing the data. So now that we've looked at the data, let's create some visualizations to better understand the relationship between different features. So the pair plot function creates here scatter plots of all pairs of features in the dataset. The hue species parameter means each species will be colored differently, helping us see how the measurements vary between them. So let's run this for now. Visualizations like this are great for seeing patterns in the data, such as which features like petal length may be useful for between flower species. Description between, okay. So as we can see here, you'll see scatter plots for each of pair measurements. Notice how petal length and petal width are different for each flower species. This could be a good indicator for classifying them later. So we have missed here the missing data, but if there is missing data, if our data set had missing values, we would need to handle them before using the data in a model. Here how we'll fill missing values using the mean. So if we run this, okay. So the fill in a function is used to fill missing values. Here we are replacing any missing value with the mean of the respective columns. This ensures we don't lose data and keep our data set consistent. The in place equals true parameter means that the changes are directly applied to the original data frame. Okay, so now we could comment that out as we don't need it. Okay, let's leave this. It's a comment because we don't have any missing. So we are now normalizing the data. To make sure our data is on a similar scale, we'll normalize it. Normalization is especially important for some machine learning models. So let's write this. We use the standard scalar from scikit-learn to normalize the columns. This means we are adjusting the values so they have a mean of 0 and a standard deviation of 1. Here we can see normalized values of for sepal length and sepal width, petal length and petal width. Normalization adjusts the features to have a mean of 0 and a standard of the division of 1. The values are now centered around 0, which means that all measurements are on a similar scale, making it easier for our machine learning models to understand relationships between them. For example, in this first row, the sepal length of 0 minus 96681 900681 means it is below the average of the data set, while the sepal length 1 of here sepal width 1.01900 is above average. Why this is important? Normalization is especially useful for algorithms like k-nearest neighbors and support vector machines, where the scale of feature can affect the model's performance. It ensures that features with larger values don't dominate the learning process. By transforming our data this way, we are preparing it for the next steps, like training a machine learning model, which we'll explore in the next video. So great job everyone. We've learned how to load, explore, clean, visualize a dataset using Python. These skills are essential when working with any type of data in a machine learning. In the next video, we'll dive in building our first machine learning model using this data. Don't forget to like, subscribe, and leave a comment if you found this tutorial helpful. Thank you.